Students, this is the second part of Irodov problem number 1.83. In this question, what is given? A particle is moving in circle of radius r. The particle travel 1/4 of the circle and the mass of particle is capital M, and I have to calculate the average value of force, magnitude of, find the modulus of the average vector of the force acting on the particle. So what I have to calculate? I have to calculate the average value of force and then its modulus. So it should be equal to mass into acceleration average modulus, and m should be taken out. So this is the magnitude of average acceleration. So we have to find average acceleration, and then we can take the magnitude of this acceleration. Now it is given that if the particle moves with constant tangential acceleration wt, the initial velocity being equal to 0. So the initial velocity of particle u is 0, and let me assume that this particle travel from this position to this position in time t. So the speed at this time is wt into t. How I can write it? Because when the tangential acceleration is constant, I can apply the formula v equal to u plus at. This is not velocity, this is speed. So the final velocity should be, the final speed should be equal to initial speed plus tangential acceleration wt into time t. So the final speed is tangential acceleration wt into time t. Yes, this is the final speed with the and this is the direction of velocity. Initial speed is 0. Now how to calculate the average acceleration? The formula of average acceleration is final velocity minus initial velocity divided by time. This is the final velocity, so it should be equal to minus omega t tau into t I cap minus the initial velocity is 0 divided by time. So average acceleration is equal to minus omega t I cap. So the magnitude of this average acceleration is omega tau. So the force of average value with magnitude is m into omega into tau. So this is the simple answer. So when initial velocity is 0, the magnitude of average force acting on the particle in the 1/4 motion on the circle is m into omega, m into tangential acceleration. So this is the answer.